solve another Leetcode problem, 354 Rossendale ever loops. So this is a very famous problem. For the Rossendale ever loop problem, we just need to, for example, this is a Rossendale. We just need to put another Rossendale inside it. For example, this is a circle. We just need to put a smaller circle inside of the circle. Yeah. And then if we have a smaller circle, we're gonna put the smaller circle still inside the circle. And finally, we just need to check how many circles we have. Yeah, so in this example, we have 3 circles. And here gonna be the similar example. We are giving a rectangle. This is a rectangle. Yeah, we just need to put a rectangle inside if there's a smaller one. If there's a smaller one, we just need to put it inside. We just need to check how many ever loops we can put. So it's gonna be the similar idea. Normally for such kind of problem, we're gonna use the sorting. So for example, if we sort the ever loop, what's gonna happen? Can this directly solve the problem? It cannot. For example, we have a ever loop. Yeah, let me just use example. For example, we have 2, 3, and now we have another one. So it's gonna be 5 and 4. Yeah. So this is by sorting. We're gonna sort it in increasing order. For the first index, 2 and 5, it is in increasing order, and then for the second index, if it is the same number for the second index, it's gonna be in increasing order as well. So for example, we have another tuple, which is gonna be 5 and 5. Yeah. So after sorting, this is gonna be 5 and 4, and this is gonna be 5 and 5. Yeah. So after sorting, how can we find how many ever loops we can put? So for example, this is a 2, 5, 2, 5, 2, 5, 5. It is okay. Now we're gonna check the second dimension. It's gonna be 3, 4, and 5. If we directly check the second dimension, 3, 4, and 5, so the answer is gonna be 3. But actually it is wrong because we cannot put 5 and 4 inside 5 and 5. So this means, what if there is the same number, this 5 and this 5? So we're gonna sort the second index in decreasing order. So we're gonna sort it in this way. Yeah. So for this 5 and 5, we're gonna sort it in this way. So here gonna be the 5, and here gonna be 4. Because we want to sort the second index in decreasing order. This is if the first index is same, this is 5 and 5, and then the second index is gonna be 5 and 4. It's gonna be in decreasing order, because in this way, what we have for the second index, it's gonna be this is 3, and this is 5, and this is 4. So what is the longest increasing subsequence? It's gonna be 3, 5, or 3, 4. So it's gonna be 2, and this is exactly the answer. And this is the only trick for this problem. Yeah. And the length of the ever loops array is 10 to the power 5. So this means we cannot solve it by using O(n) squared time complexity. We cannot use 2 for loops. We have to use a greedy algorithm to solve it in n log n time for finding the longest increasing subsequence. So now for this problem, we're gonna try the greedy idea to solve the problem. Yeah. So now let's just try to solve it. So for sort, we're gonna use a lambda function. So k gonna equal to lambda. So x gonna we're gonna sort it for the first index. It's gonna be x0, and for the second index, it's gonna be x1. But it's gonna be sorted in decreasing order for the second index, and for the first index, we're gonna sort it in increasing order, because only in this way, if we take out if we take out the second index, we can directly find the longest increasing subsequence. Now we're gonna take out the second index for all the numbers. So b for a, b inside the ever loops. Yeah. Now we're gonna define the function. So I'm gonna define f. This is gonna be the greedy idea to find the longest increasing subsequence. So inside I'm gonna give nums, and here I'm gonna give f array. so it's going to be an empty array. So for any number inside the nums, I gonna equal to bisect left. So inside it's going to be f and this number. So if I equal to length of the f array, so we can directly append it this number. So otherwise fi gonna equal to n, and we're gonna return length of the f array. Yeah. So finally, we just need to get the final answer. So we're gonna return f with nums array, because this is for calculating the longest increasing subsequence, and this is for taking out all the numbers after sorting for the second index. Because for the first index it has been sorted in increase order, and for the second index it is sorted in decrease order. Now what are we gonna do? We just need to find the second index. We just need to find the second index like 3, 5, and 4. Because for the first index, it always meets the condition. Maybe you're gonna wonder, for the first index, this is 5, this is 5, is that okay? Because I'm looking for the longest increasing subsequence, but this 5 and 5, they are equal, is that okay? But for the second number, it might not equal. For example, this is 5 and this is 4. So this is okay. So this means if this is 5, this is 4, this number is 5, this number is 4. Definitely, it can never be in increasing, because it is sorted in decrease order. Even it is the same number. For example, if this is 5, this is 5, 5, and this is also 5, 5. It is okay. So for the final one, it's going to be 3, 5, and 5. But this is also okay. For we are calculating the longest increasing subsequence. It is strictly increasing. It can only be 3 and 5. So the answer is going to be 2 as well. This means 5 and 5 can never put into another 5 and 5. Now let me just run it to check if it works. Now let me just submit it. As you can see, it passed for all testing cases, and it's pretty fast. I think it's all about it. Thanks for watching. See you next time.